Welcome back. So this is exercise 3.3 and this exercise is completely dedicated to substitution method. So whatever problems we solve in this exercise will be following the substitution method. We have already done enough example and the method and technique how substitution method works. So now we'll directly jump into the problem. So the first question is x plus y equal to 14, x minus y equal to 4. So these are the two equations given to us. We can just see that a1 by a2 is not equal to b1 by b2. Therefore you will be getting a unique solution for this problem. Okay, so substitution I will just recap once again. From first equation or the second equation, you can pick any one of them. So here I have taken equation 1 and from that I have got y is equal to 14 minus x and I make this as a new third equation. Once I obtain the third equation, I already told you, if you are obtaining this third equation from the first equation, you are supposed to substitute this third equation in the second equation. So I am substituting this third equation in 2. In place of y, I put 14 minus x. So in place of this y, I put 14 minus x. So I get x minus of 14 minus x is equal to 4. So when I do the arithmetic, I get 2x is equal to 18 or x is equal to 9. So I have got one variable which is 9. Next, since I already got one of my variable as 9, in the third equation I directly see if I substitute the x value, I will get my y value. So if I substitute x as 9 in the third equation, I will get y as 5. Therefore the solution is 9, 5. As we saw, it is a unique solution type. So you got one value for x and one value for y. And moving on to the second one, here we have s minus t equal to 3 as the first equation and s by 3 plus t by 2 equal to 6 as the second equation. So again I am doing the same thing, I am taking the first equation and I am finding s from it. So s will be 3 plus t goes to the other side. So I get the new third equation. This third equation is substituted back in the second. So I get, in place of s, I put 3 plus t. So I get 3 plus t by 3 plus t by 2 is equal to 6. Then I take the LCM. LCM is 6. So this entire term gets multiplied with 2 and this term gets multiplied with 3. So I get 6 plus 2t plus 3t by 6 is equal to 6. So when I combine the like terms and cross multiply, I get 6 plus 5t is equal to 36. Now taking 6 to the other side, I get 5t as 30, t will be 6. So after obtaining one of the variable, I can directly substitute this t equal to 6 in the third equation and obtain what is my s. So s will be 3 plus 6 which is 9. Therefore, this is again unique solution type problem because a1 by a2 is not equal to b1 by b2. So we got one value of x, I mean s, and one value of t. Moving on to the third one. So here we have 3x minus y equal to 3 as the first equation, 9x minus 3y equal to 9 as the second equation. If you look into this equation, here your a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So this is going to be infinitely many solution type. So we'll see how to approach it in substitution method. So again I take any one of the equation, I picked up the first one. So I get x is equal to 3 plus y divided by 3 and make that as my new third equation. I substitute this third equation in the second equation. So I get 9 times, in place of x I put 3 plus y by 3 minus 3y equal to 9. I see that this 3 and 9 cancels 3 times. So I will be left with the 3 here. So multiplying the 3 inside, 3 and 3 becomes 9, 3 with y becomes 3y. This minus 3y and 9 is written as it is. This plus 3y minus 3y cancels each other and we get 9 is equal to 9, which is an obvious result. So whenever we end up like this, I have told you earlier, you have to assume one of the variable as k. So I have taken y as k in this, where k belongs to any real number. So when I take y is equal to k, I can directly substitute that y equal to k in the third equation and obtain my x. So when I substitute that, I get x is equal to 3 plus k by 3. Therefore, my x will be 3 plus k by 3 and my y will be k is the solution. I can substitute any value of k for y. So I will be obtaining several sets of answers which will be the solution to the given equation. So this is the fourth question. It is given that 0.2x plus 0.3y equal to 1.3, 0.4x plus 0.5y equal to 2.3. So the equation is with decimals. So what we are trying to do is we are multiplying the entire equation with 10. So that you get 2x plus 3y equal to 13, 4x plus 5y equal to 23. This does not change anything from whatever is given, since we are multiplying that number commonly to all the elements of it. So from this we take, why I have done this is just for simplicity. So I have taken the first equation and I have taken got x is equal to 13 minus 3y by 2 from this and I obtained the new third equation. This third equation is then substituted in the second equation. So when I substitute x value in the second equation, I get 4 times 13 minus 3y by 2 plus 5y equal to 23. Then I cancel this 2 and 4, it cancels 2 times. Then I multiply this 2 inside, it becomes 26x minus 6y plus 5y equal to 23. Now I collect all y one side and the numbers to the other side. I get minus y equal to minus 3, cancelling both the minuses on either side to get y is equal to 3. So after obtaining one of the value which is y equal to 3, I am substituting this y equal to 3 in the third equation to obtain the value of x. So when I substitute y as 3, I get 13 minus 3 times 3 by 2, which is 13 minus 9 by 2, which is 4 by 2. So my value of x is 2. So I have obtained 2 as the solution for x and 3 as the solution for y. And if you see the equation also, it is a1 by a2 not equal to b1 by b2. Therefore, you got a unique solution answer. Now moving on to the fifth question. The equation is root 2x plus root 3y equal to 0 and root 3x minus root 8y equal to 0. So this is equation 1 and equation 2. I have taken the first equation and I have obtained x from it. So x will be minus root 3y by root 2, which is my third equation. I substitute this third equation in the second. So I get root 3, which is already there. This x is replaced with minus 3 root y by root 2, which is written here. Then minus 8 root y equal to 0. So when I try to simplify this, root 3 and root 3 becomes 3 and the negative sign is remained. Y by root 3 minus root 8y equal to 0. When I take the LCM would be root 2. So this will be minus 3y and root 8 would get multiplied with root 2, which is root 16. Y is equal to 0. We know root 16 is nothing but 4 because 16 is a perfect square. So it is going to be 4. So minus 3y minus 4y equal to 0. I will obtain minus 7y is 0, which otherwise means my y is 0. So the answer for y is 0. After obtaining my value of y is equal to 0, I substitute this in the third equation to obtain my x value. So when I substitute y as 0, I see that my x is also 0. So the solution for this equation is x is also 0, y is also 0. So again, this is a unique solution type. So we got one specific answer for both x and y. Moving on to the sixth one. We have 3x by 2 minus 5y by 3 is equal to minus 2 as the first equation and x by 3 plus y by 2 equal to 13 by 6 as the second equation. And here it's been fraction, so it will take a little more steps to solve it. So first what we do, I'm taking the first equation. I have written 3x by 2 is equal to minus 2 times this 5y by 3 goes that side, so it becomes positive. I have taken LCM. So 2 has become minus 6, the 5y is remained as it is. So I have 3x by 2 is equal to minus 6 plus 5y by 3. So if I want to get only x, I need to take this 3 by 2 to the other side. So 3 by 2 taken the other side will become reciprocal, which is 2 by 3. So my new x value that I get will be minus 12 plus 10y by 9. So this is my third equation. So once I obtain the third equation, I substitute the third equation in the second because I obtained the third equation from the first. So I'm trying to substitute 3 in 2. So when I substitute 3 in 2, it is going to be x by 3. That is my second equation. So in place of x, I put minus 12 plus 10y by 9, which is written there. And there is a by 3 there, which is written here. Then we have y by 2 and 13 by 6 as usual. Then when I try to simplify this, 9 and 3 both are in the denominator, so they get multiplied. So I get minus 12 plus 10y by 27 plus y by 2 is equal to 13 by 6. I will continue this here. So the last step that we have obtained is minus 12 plus 10y by 27 plus y by 2 is equal to 13 by 6. So the next step that we will be doing is, we will be taking LCM. The LCM for this would be 54, 27 and 2. So this entire equation gets multiplied with 2 and this y gets multiplied with 27. So I get minus 24 plus 20y plus 27y is equal to 13 by 6. So if I do the like terms, I'll get 24 plus 47y by 54 is equal to 13 by 6. So now I can cancel the 6 and 54 9 times. So I'll be getting minus 24 plus 47y by 9 is equal to 13. When I cross multiply, I'll get minus 24 plus 47y is equal to 117. I'm taking this 24 to the other side. So I have 47y is equal to 117 plus 24. So this becomes 47y is equal to 141 when you add this. So you'll be getting y is equal to 141 by 47. Like this cancels it 3 times. So your y is 3. So after obtaining y as 3, you substitute this y equal to 3 in the third equation, so you will get the x directly. So your x would be minus 12 plus 10 times 3 divided by 9. So you will be obtaining minus 12 plus 30 by 9, which is 18 by 9. So your x is 2. So the solution that we have for this equation your x value is 2, y value is 3. And it is evident a1 by a2 is not equal to b1 by b2. So we got a unique solution. Second question. So in this they have given two equations, and also they have told after getting the value of x and y from the equation, you have to substitute here and find the value of m. So let's start first solving the equation. It's 2x plus 3y equal to 11, 2x minus 4y equal to minus 24. So I have taken the first equation, and from that I have obtained x as 11 minus 3y by 2. So this becomes my third equation. I am substituting equation 3 in 2. So when I substitute it in 2 remains as it is. In place of x I put 11 minus 3y by 2. So 11 minus 3y by 2 minus 4y is equal to minus 24. This 2 and 2 gets cancelled away. So I will be left with 11 minus 3y minus 4y equal to minus 24. So when I simplify and take the like terms to one side, I get minus 7y is equal to minus 35. Minus minus would cancel. I will get y is equal to 35 by 7, which is y is equal to 5. So after obtaining y is equal to 5, I substitute y equal to 5 in equation 3 to obtain my x value. So x would be 11 minus 3 times 5 by 2, which is 11 minus 15 by 2. So x would be minus 4 by 2. So I will get x as minus 2. So I have got minus 2 and 5 as a solution for x and y on solving this equation. Now the additional part is you have to find the value of m using the same x and y values in this relationship. We know our y is 5, m remains as it is. In place of x I have put minus 2 because x is minus 2 plus 3. So when I simplify this, I will see that my m will be minus 2 by 2. So m is equal to minus 1. This is the first subdivision in the third question. So here they have said there are two numbers, and I have assumed one number to be x and the other number to be y. The relationship given is the difference between the two numbers 26. So out of the two numbers, I have assumed my x to be the greatest number and y to be the smaller number. This is not a condition. You can even choose y to be the greatest and x to be the smallest. Since I have considered my x as the greatest number, so x minus y is 26. By that I get the first equation. Then it says the larger number is 3 times the smaller number. So x is equal to 3 times y. This is my second equation. Now here it's directly x is equal to 3y. So I can substitute 2 directly in the first one. So when I substitute 2 in 1, I get 3y minus y is equal to 26. So then I simplify, I get y, 2y is 26, y is equal to 13. After obtaining y is equal to 13, I substitute the value of y equal to 13 in the second equation in order to obtain my x value. So x will be 3 times 13, so x will be 39. So x is 39 and y is 13 is the solution for this equation, and x 39 and y 13 are the two numbers that they have asked us to identify. So this is the second subdivision in the third question. So here they have given there are two angles which are supplementary. So I have taken one angle is x degree, the other angle is y degree, and I have also assumed x is greater than y. Since they are supplementary, the sum of those two angles must be equal to 180. So that is my first equation. And they say the larger angle is exceeding the smaller angle by 18. So the larger angle minus the smaller angle should be 18. That is my second equation. Now I have taken the second equation. From second I have obtained x is equal to 18 plus y, and that is the third one. And this third equation I am substituting it in the first one. So when I substitute in the first one, I get 18 plus y equal to 180. I get 2y is equal to 162. When I simplify this further, I get y is equal to 81 degrees. So after obtaining one angle as 81 degrees, I substitute this y equal to 81 degrees in the third equation. So when I substitute in the third equation, I get x is equal to 18 plus 81. So x would be 99 degrees. So the angles are 99 degree and 81 degree. So these are the combination of the angles that is given to us. The third question. So in this they have told they are buying bat and ball for some cost. So I am assuming the cost of one bat is x rupees and the cost of one ball is y rupees. So according to the question, they are buying 7 bats and 6 balls for a cost of 3,800 rupees, which becomes our equation 1. And later 3 bats and 5 balls for 1,750 rupees, which becomes our equation 2. I have taken the second equation and I have obtained x is equal to 1,750 minus 5y by 3 and made that as a third equation. And I have substituted the third equation in the first one. So 7, in place of x I have substituted this, which is 1750 minus 5y by 3, then plus 6y is equal to 3,800. On simplifying this, I multiply 7 inside. When I multiply 7 inside, I get 12,250 minus 35y by 3 plus 6y equal to 3,800. After taking LCM, it is the same thing. The 6y around will turn to 18y and I will be having this number. When I combine the like terms, I will get 12,250 minus 17y, that is equal to 11,400 divided by 3. Then I have taken this 3, I have cross multiplied and I have obtained this. Now I take the numbers to the other side. I get minus 17y is equal to minus 850. Minus minus would cancel. My y would be 50. So the cost of one ball is 50 rupees. After obtaining the cost of one ball, that is y, I substitute this value in the third equation to find the cost of a bat. So x would be 1750 minus 5 times 50 divided by 3. This would be 1500 by 3, which means x will be 500. So 500 is the cost of a bat and 50 is the cost of a ball. This is the fourth subdivision. So here they say in a taxi there is fixed charges and charges according to the distance. So we have assumed the fixed charges to be rupees x and the charge per kilometer as rupees y. So according to the question, for 10 kilometers we will be getting x plus 10y equal to 105, which means the fixed charge plus 10 y represents 1 kilometer. So for 10 kilometers it's going to be 10 times y, that is going to be 105. So this is the equation 1. Then for 15 kilometers they pay 155 rupees, which is x plus 15y equal to 155. So this is our equation 2. I have taken the first equation, I have got x is 105 minus 10y, that becomes my equation 3. I substitute third equation in the second one. So when I substitute it here, I get 105 minus 10y plus 15y equal to 155. When I solve it, I get 5y is equal to 50, which means y is equal to 10. Therefore the cost per kilometer is rupees 10. Now I substitute y is equal to 10 in equation 3. Then I substitute it here, I get 105 minus 10 times 10. So x would be 105 minus 100, which is 5. So the fixed cost is going to be 5 rupees. And also there is another part of the question which says what will be the amount paid if they travel 25 kilometers. We know it's going to be fixed charge plus the distance traveled into the cost of 1 kilometer. So it's going to be x plus 25y. So x we have obtained as 5 and y we have obtained as 10. So it's going to be 255 rupees. So the cost for traveling 25 kilometers with this taxi fare would be 255 rupees. This is the fifth subdivision. So here they have given there is a fraction. So I am assuming the fraction with the numerator as x and denominator as y. And they have told when 2 is added to the numerator and 2 is added to the denominator, the fraction, new fraction becomes 9 by 11. And one more condition is when 3 is added to the numerator and 3 is added to the denominator, the fraction becomes 5 by 6. So this is directly not in the form of equation. So we have to reduce it to the form of linear equation type. So what we do, we cross multiply, we get 11x plus 22 is equal to 9y plus 18. I combine x and y on one side and take the numbers to the other side. So I get 11x minus 9y equal to minus 4. So this is my first equation. Again from this I do the same thing, I cross multiply, I'll get 6x plus 18 is equal to 5y plus 15. I collect x and y on one side and numbers on the other side. Then I get 6x minus 5y equal to minus 3. This is my second equation. So I have got my first equation and second equation. I have taken the first equation and I have obtained x from it. So x will be minus 4 plus 9y divided by 11. So this becomes my third equation. Now I substitute my third equation in the second one. So when I substitute it in the second one, I get 6 times. I replace this in place of x. Then I get minus 5y is equal to minus 3. So when I simplify it further, when I multiply 6 inside, I get minus 24 plus 54y divided by 11 is equal to will be minus 5y equal to minus 3. So when I take LCM, I'll get minus 24 plus 54y minus 55y is equal to minus 3. Then again I cross multiply, then I'll be getting minus 24. 54y minus 55y becomes minus y and 11 into 3 becomes 33 and the minus remains as it is. So when I keep y on one side, take the number to the other side, I get y is equal to 9. So I got the fractions denominator as 9. Once I got y as 9, I substitute this y equal to 9 in the third equation. So I get minus 4 plus 9 into 9 divided by 11. Minus 4 plus 81 by 11, which is 77 by 11. 77 by 11 is nothing but x is equal to 7. Therefore the fraction would be 7 by 9. That is the required fraction. This is the last question in exercise 3.3. So here they have given the age relationship between Jacob and his son. So I have assumed the present age of Jacob as x years and his son as y years. So according to the questions, 5 years hence, which means from now 5 years. So x will become x plus 5, y also will become y plus 5 in 5 years from now. Since their present ages are x and y, after 5 years they will be added with 5 for both of them. He says his age will be 3 times the age of his son. So x plus 5 will be 3 times y plus 5. So when I simplify this by using the normal multiplication, I get x plus 5 is equal to 3y plus 15, or when I bring this 3y the other side, I get x minus 3y equal to 10. I obtain the first equation from this. There is one more condition given 5 years ago. So I have taken the present ages as x and y. So 5 years ago, the age of Jacob would be x minus 5, his son would be y minus 5, and the relationship is the age of Jacob would be 5 times the age, 7 times the age of his son. So when I again simplify this, I get x minus 5 is equal to 7y minus 35. I then bring this 7y the other side, so I get x minus 7y equal to minus 30. This is my second equation. So now I have taken the first equation and I have taken x from it. So x would be 10 minus 3y. So this gives my third equation. Now I substitute this third equation in the second equation. So when I do that, in place of x I put 10 plus 3y. Then I have this minus 7y equal to minus 30. So when I simplify this, I get minus 4y equal to minus 40. Y would be 10. So I have obtained the age of his son to be 10 years. Now I substitute y equal to 10 in this equation 3. So when I do that, I get x is equal to 10 plus 3 into 10. So x would be 40. So the age of Jacob is 40 and his son is 10. Thank you. We'll continue with exercise 3.4 in the next lecture.